This chapter, we get to discuss ratios and percents. Percents are a type of ratio. It's literally per 100. Look, there's a reason there's 100 cents in $1, and there's 100 years in a century, and there's 100 centimeters in a meter. Cent is a prefix for 100. So, or a suffix in this case. Well, I mean, it means 100. It's something related to 100. That's where the etymology of percent came from. It's literally per 100. Now, we start with ratios and rates in general. Ratios written as 7 to 12 as you read this, or 7/12 are different ways to write the same ratio. Ratios should be written in simplest form, unless you are comparing two ratios. Because, guys, comparing, say, 3/4, and then 8/12. How do we compare them? Well, if we have the same denominator, we can see which one has the bigger numerator. Of course, 8/12 is not actually in simplest form, but the general point is that if you use the same denominator, that's useful for comparisons. But other than comparisons, you should generally write your ratios in simplest form. Now, example 1. Express the ratio of 6 feet to 16 inches. Well, 6 feet is 6 times 12, or 72 inches. So, 72/16 is equal to 72 is 8 times 9. 16 is 2 times 8. So, you got 9/2. This is the fraction. If you want a mixed fraction, you want 4.5. However, when we're doing ratios, it can be debatable, depending on convention, whether improper fractions are preferred when you're expressing a ratio. For example, 9/2, if you write this in ratio form, if you convert it straight to fraction form, it's this. So, should we actually change it to mixed fractions? That depends on convention, but the improper fraction is always okay. At least, in my experience, the improper fraction and the ratio are always just fine. So a unit rate uses a denominator of 1, such as 30 kilometers per hour. What does this actually mean? Well, this means 30 kilometers per 1 hour. That's a unit rate, because it's a single hour, a rate per 1 unit of the denominator. Express the ratio of $10 for 4 fish as a unit rate. Round to the nearest cent if necessary. Well, in this case, it's not, because 10/4 is equal to $2.50 per fish. Or $2.50 per fish, depending on convention and how uptight your teachers are about it. Why is it 2.50? It's not because it says round to the nearest cent. It's because when you write amounts of money, if you don't have a whole number of dollars, like if you have, say, 50 cents or 40 cents, you write all the way down to the cent. Okay, let's do some exercises. Express each ratio as a fraction in simplest form. 4 weeks to plan 2 events. Well, 4 to 2 So this is 4 over 2, which is equal to 2. And this would be weeks per event. 9 men to 18 water bottles. Well, you got 9 to 18, which is equal to 9 over 18 in fraction form. And then simplest form, 1/2 men per bottle. If we wanted to express it as a unit rate. Then, yeah, we would just give these numbers. But at the same time, this is the appropriate unit for the ratio we have, because this is 9 men divided by 18 bottles. So the units are going to be men over bottles. So men per bottle. Yeah. 7 wallets to $189. Well, if these dollars are in these wallets, this is how many money? Wait, we have 140 if it was 20 times 7, and then we have 49, which is 7. Oh, hey. 7 over 189. So 1 over 27. And this is wallets per dollar. You can find the unit rate by simply dividing the numerator by the denominator. The fraction you get is gonna be your unit rate. Well, unit rate with respect to the denominator. 8 teachers to 216 students. Up here, if this was dollars put in these wallets, or that were found in these wallets, they aren't carrying much cash around, I see. Like $27 is not much in a wallet. But if it was the price of the wallets, well, that depends on what dollars you're spending. So it depends on the currency and the local prices. 8 teachers to 216 students, on the other hand, for most of the world, this would be a pretty small class. For developed countries, on the other hand, well, that depends. So, 8 teachers to 216 students, that equals 8 over 216. What happens if we divide 216 by 8? 200 divided by 8 is 25. 16 divided by 8 is 2. So 25 plus 2 is going to be 27. 1/27 teachers per student. So for each teacher, there's 27 students. Express each ratio as a unit rate. Round to the nearest tenth or nearest cent if necessary. $59 for 5 tickets. Well, $59 over 5 tickets is equal to 59 divided by 5 gives you 11.80 dollars per ticket. As before, when you have a not whole dollar amount, you're obligated to write to the nearest cent, even if the last digit is going to be 0. 6.49 for 4 cans of soup. That's going to be 6.49 over 4 cans, which is equal to 1.6225 dollars per can. Right, that's approximately $1.62 per can. Now, how about $299.99 for 7 people? Well, that's $299.99 over 7, which is equal to 299.99 divided by 7. Oh, it's approximately, we're rounding just on the first step right away because we used a calculator, $0.86 per person. Okay then. What about 560 kilometers in 6 hours? Well, that's 560 kilometers over 6 hours. So 560 divided by 6. Oh, it's 93 and 1/3. 1/3 kilometers per hour. Or approximately, it's said to the nearest tenth, right? Check back to the problem, guys, if you have any doubts at all, ever. So, we end up with approximately 93.3 kilometers per hour. Proportional and non-proportional relationships. Two quantities are proportional if the ratio between them is constant. Or the rate is constant. If you graph them, then they will form a straight line. Proportional relationships can be described by the form y equals kx, where the k is the constant ratio. Now, if you graph it, k is the slope of the line. And because there's no y-intercept here, i.e. there's no y equals kx plus b for some constant, the usual form for the slope y-intercept form for lines is y equals mx plus b. But it doesn't really matter. It's just the slope, the ratio between the two measurements. Oh, how much each measurement increases or decreases depending on the other one's fluctuations. Now, there's no constant term, which means that if you graph this, it must pass through the point 0, 0, the origin, or O, 0, 0. The constant ratio is called the constant of proportionality. Realistically speaking, you will not encounter this term all that often, and you're probably going to get just the constant ratio instead. But you kind of have to know this term exists in case somebody decides to use it on you. All right, example 1. Determine whether the numbers in the table are proportional. Time in minutes, 1, 2, 3, and 4. Distance in yards, 300, 600, 900, 1200. Well, you realize that this is plus 1, this is plus 1, this is plus 1, and this is plus 300, and this one's same, and this one as well. So, is this enough to prove that these numbers are proportional? The answer is no, because you don't have a point 0, 0 here. You have to show that T to D is equal to 1 over 300. Of course, you could also give it the other way, which is equal to 2 over 600, which is equal to 3 over 900, which is equal to 4 over 1200. So, the ratio of the variables is constant. Thus, the numbers are proportional. They're proportional. Okay then. Let's say we have a square. A square's perimeter is proportional to the length of one of its sides. Well, let side length be S. Then P is equal to 4S. What would be the perimeter of a square with 9-inch sides? P is equal to 4 times 9, so equals 36. And there's something important here, guys. There were units attached, so we have to put inches. And depending on convention, we might want to state that, oh, it's the perimeter that equals this. Because a lot of teachers like it when you restate, oh, what's the last line equaling to? I mean, you might have restated it only a line before, but it's still easier to find. Like, you're looking through your previous math equations while you're working down to here, and it's like, where's the P equals whatever line? I can't find it. That's awkward, right? Yeah, that's why a lot of teachers like it. So exercises. Determine whether the sets of numbers in the tables are proportional. So here we have compare 6 over 4, 9 over 6, 12 over 8, and 15 over 10. They all equal 3 over 2. Now, population in hundreds of thousands versus the years. Well, you gotta compare the fractions, or compare the ratios. Compare 2.3 over 1 equals 2.3. 3.4 over 2 equals 1.7. Unequal ratios. Not proportional. And if the ratios are equal, they are proportional. Is that okay, guys? If the ratios between the variables are equal, they are proportional. If they're not equal, then it's not proportional, because if you draw a line through all the points, assuming you can actually draw a straight line through them, which in this particular case you actually couldn't, because for this increase of 1, that increased by 1.1, and then the next one, well, this next one was a 0.7 up here, and this next one was another 1.1. So no, it actually was not even a straight line. But anyway, even if you drew a straight line between the first 2 points, it would not pass through 0, 0. A school is repainting some of its classrooms. Each classroom is repainted with 5.5 gallons of paint. Write and solve an equation to determine the gallons of paint the school must purchase if they repaint 18 classrooms. Let P be gallons of paint needed, and C the number of classrooms to repaint. We're looking at P equals 5.5 gallons per classroom multiplied by the number of classrooms to give us gallons. In this case, it's 5.5 times 18 classrooms, which would give us 99 gallons. Okay then. You might want to put P over here again. Just saying. We just talked about how two measurements can be proportional to each other. And we said that we had to prove that by showing that the ratios between the measurements stayed the same. And what are proportions? Well, a proportion is an equation that says two ratios are equal. You can use cross multiplication, sometimes at this grade level called cross product, to solve a proportion. For example, let's solve this proportion. 12.3 divided by C is equal to 3 over 4. Cross multiplication would be, we multiply the 4 over, and we multiply the C over. What we're actually doing is you're multiplying both sides by 4C. By multiplying both sides by 4C, on this side, it's equivalent to getting rid of the C and multiplying by 4. On that side, it's going to be getting rid of the 4 and multiplying by C. So 3C is equal to 12.3 times 4. You might notice something interesting here. You can cancel this. This is 4.1 times 3. So C is equal to 4.1 times 4, so that's 16.4. Exercises. Solve each proportion. 36 over 15 equals 24 over S. Well, before we cross multiply, we can already simplify this. How? Divide both sides by 12, and we get 3 and 2. So, and then we can cancel this, and we get 5 down here, and the top becomes 1, which means 1s is equal to 2 by 5 equals 10. Okay, here you can cross multiply, sure, but you can also do some canceling first. 6 by 8 is 48. So you got 41 times 1 equals 6W. W is equal to 41 over 6. And if you prefer using improper fractions, you can leave it at that. But mixed fractions, you're going to have to change it. Okay then, how about 3.4 over 4.4 equals D over 80? I mean, you could cancel this down to a 1.1, and then the 80 could become a 20. Sure. Does this actually do anything useful? Not particularly. 3.4 times 20. 4 times 20. Okay, D is therefore equal to 34 times 2, which is 68 over 1.1. So, well, I mean, it would be 61.81 repeating if you wanted it in decimal form. But as a fraction, 680 over 11, and then we get 61, and then we have a little bit left over. Specifically, we have 9 over 11 left over. How do I know that? Well, besides the fact that it's 0.8181 and so on, there's also this ends in 1. This also ends in 1. The product must end in 1. If you begin at a whole number of tens and then you minus something that ends in 1, you're going to end up with something that ends in 9, assuming you don't end up with a negative number. So, this is D. What about this? We can cross multiply, right? Well, let's cancel first. 0.1, 1.5. So divide both sides by 3. 1.5n is equal to 0.1 times 15.5. So n is equal to 1.55 over 1.5. Which leaves us with 155 over 150. We divide both top and bottom by 5, and we end up with 31 over 30. And this will be 1 and 1 over 30. Now, 5.1 over 17 is equal to 1.3 over p. Hey, guys, what's 51? 51 is 17 times 3. Okay, then. That means 5.1 is 17 times 0.3. 0.3, and this becomes 1. So we're looking at 0.3p is equal to 1 times 1.3. Okay then, p is equal to 1.3 over 0.3. So 13 over 3. Or, if you want a mixed fraction, 4 and 1/3. Okay, now v over 3.9 is equal to 1 over 3.2. In this case, you don't need to cross multiply entirely. You just multiply the 3.9 out of the denominator here and you got V. 3.9 over 3.2. If you like, you can rearrange this to 39 over 32, or you can just go straight to 1 and then 7 over 32. Because you're going to end up with 0.7 left over 3.2, so yeah, you might as well just write 7 over 32. Right, a lot of teachers like it when you do this, so there we go. Scale drawings and models. A scale gives a relationship between the measurements on the drawing or model, including, say, maps, and the measurements of the real object that the map or scale, model, drawing happens to represent. So let's say we have a map that shows a scale of 1 inch equals 6 miles. The distance between two places on the map is 4.25 inches. What is the actual distance? So 6 miles is equal to 1 inch on this map. You have 4.25 inches times 6 miles per 1 inch, because you're converting it from the map to the actual distance. And you got the inches cancel out, and 4 times 6 is 24. 0.25 times 6 is 1.5. So 25.5 miles. Okay then. Exercises. Suppose we have architectural drawings for an office building, and the scale is 0.25 inches equals 5 feet. Well, it seems that this drawing is made in the United States, because in Canada, I'm pretty sure they would use however many centimeters to meters instead. Like 1 centimeter equals 1 meter, probably. That's pretty common. Find the actual length of each room. Okay, so the lobby, the drawing distance is 1.9 inches. So you multiply by 5 feet per 0.25 inch. You could also convert the scale and make it 1 inch to 20 feet. Because 5 divided by 0.25 is equal to 20. So, you could go 1.9 inches multiplied by 20 feet per 1 inch. So you just multiply by 20 and change the units to feet, which would give you 38 feet. 1.25 inches times 20 feet per 1 inch. Yeah, it's very useful to convert your scale into a unit rate. If you convert it into a unit rate, you can just do a simple multiplication. 1.25 inches times 20 feet per inch gives you 25 feet. For the CEO's office, the copy room is at 20 feet per inch. At half an inch would be 10 feet. 0.6 inches for the CEO's secretary's office is going to be, multiplied by 20, we get 12 feet. Vice President's office, 0.95 inches times 20 feet per inch, you get 19 feet. Library, 1.8 inches times 20 feet per inch, 36 feet. Storage area, 2.25 inches times 20 feet per inch. It's useful to occasionally write down your scale again, or your converted scale in this case, if the thing you're looking through is too long for you to look at all of it at once. 2.25 inches for the storage area at 20 feet per 1 inch. That's 2.25 times 20, which gives you 45 feet. 1.7375 inches at 20 feet per 1 inch. This number multiplied by 20 is what? Oh, it's 17.375 times 2. 0.375 times 2 gives you 75. So you're dealing with 34.75 feet. Okay, then what about the manager's office? It's 0.625 inches. And 20 feet per 1 inch, that's 6.25 times 2, or 12.5 feet. The mail room, 2.5625 inches, well, times 20 feet per inch, that's 25.625 times 2. So we're looking at 51.25 feet. Boiler room, 3.825 inches times 20 feet per inch, 3.825 times 20, that's 38.25 times 2. So we got a 0.5 at the end. And then 38 times 2 gives us 76.5 feet here. Okay, then. What about conference room A? 2.64 inches. At 20 feet per 1 inch, that's 26.4 times 2. So 0.8 at the end. And then 52. This is, of course, in feet. Now, 0.955 inches at 20 feet per inch, that's 9.55 times 2, which points us to 19.1 feet. .5 inches for the cafeteria at 20 feet per inch. That's 25 times 2, which is, of course, 50 feet. Kitchen, 2.1 inches times 20 feet per inch. That's 42 feet. For scale diagrams or drawings or maps, you multiply by the scale of the map with the appropriate units in the numerator and denominator so that your on-map measurement or the real-life number can have its unit canceled and be converted into whatever you want. Like, say you have miles per inch, and you want to go from inches to miles. Yeah, that's because you want your inches to cancel and go from, oh, on the map it's this many inches, in real life it's this many miles. If you want to go from, say, kilometers in real life to centimeters on a map, then you want your scale to be centimeters per kilometer, so that the kilometers can cancel and you end up with centimeters for your unit. This is important, guys. When you do scale drawings, that's how you do it. That's how you convert things. Make sure the units line up and you won't go wrong. Although it is kind of convenient if you can have them be unit rates, such as miles per 1 inch or centimeters per 1 kilometer. sometimes instead of centimeters per kilometer or whatever, you actually have the map ratio be given as something like 1 to 100,000. This means that 1 on map, 1 of whatever unit on the map, is 100,000 in reality. So 1 centimeter on the map is 100,000 centimeters in reality. So 1,000 meters or 1 kilometer. Make sure that you put the appropriate unitless measurements on the top and bottom for your conversion. Because you don't want to go, oh, I got 2 centimeters on the map times 1 over 100,000 is equal to 2 over 100,000 centimeters in real life. Unless you're making a map of something really small, like say a computer chip, I don't think that's the way the ratio is supposed to be used, guys. Just make sure that your results actually seem plausible, okay? And make sure that you use the correct numerators and denominators. Fractions, decimals, and percents. Example 1. Express the percents as fractions. 24% and 225%. Well, 24%, a percent literally means a fraction out of 100. So it's 24 out of 100. And we can cancel a what? We can cancel a 4 from both top and bottom, because they're both multiples of 4. 25 and 6. So it's 6 over 25. 225% is, hopefully this section is a review, guys, because we did this in previous grades. So 100 is 4 times 25, so 4. And 225 is 9 times 25. So it's equal to 9 over 4. Or, you could also say it's equal to 2 1/4. In fact, when you're doing this type of greater than 100%, you can actually take out the whole number part. Like you can just go 2 25 over 100. And then that's 2 1/4. Yeah. Okay, let's express these percents as decimals. 216%. Well, expressed as a decimal, that's 2.16, because 100% is 1.00, or just 1. 21.57%, that's 0.2157. Because remember, guys, percent literally means per 100. So this is 21.57 divided by 100. If we actually do the division, we'll find that the decimal place just moves 2 places, and we get rid of the percent symbol. Example 3. Express the fractions as percents. 29 over 5. Guys, that's how much over 100? 25 times 4 is 100. So 29 times 4 is 116. So that's going to be 116%. 377 over 1,000 is equal to 37.7 over 100 equals 37.7%. Now, example 4. Express the decimal as a percent. 3.17. Guys, this is equal to 317 over 100. So it's equal to 317%. Let's do some exercises. Express each percent as a fraction or mixed number in simplest form and as a decimal. 12% as a fraction or mixed number in simplest form and as a decimal. Well, the decimal is easy. It's 0.12. It's also equal to 12 over 100, which, if we divide both the numerator and denominator by 4, we get 3 over 25. 224%, well, that's, so 2.24 is the result when you divide 224 by 100. Now, what about as a fraction or mixed number? Well, in this case, it's going to be a mixed number, so it's 2 and 24 over 100. Okay, and then we divide both numerator and denominator by 4, and we get 2 and 6 over 25. Now, 98% is equal to 0.98, or 98 over 100, which is, of course, going to, both of these are divisible by 2, so 49 over 50. 0.6%, that's equal to 0.006, because percent is divided by 100. And we evaluate to get this decimal, and that's equal to 6 over 1,000. Or 0.6 over 100 if you insist. This factors out a 2 from both numerator and denominator, and we get 3 over 500. Now let's express each of these decimals or fractions as a percent and round to the nearest tenth of a percent if necessary. 7.3. We know that 100% is literally 1, because percent means per 100. So 7.3 is 730%. You can think of this as times 100% if you insist, because all that does is times 1. It doesn't change the value. Here, 0.096, okay, multiplied by 100, that moves the decimal place 2 places, and you get 9.6, and then you add the percent symbol. 43 over 99, well, wait, do we remember any useful rules? We could use our calculators, sure, but a useful rule is that if you have 0. A, B, C, D, E, F, and so on, that repeats itself, that's equal to A, B, C, D, E, F, and so on, over 99999, and so on. Same digit number as numerator. So 43 over 99 is equal to 0.43 repeating. You can try long division and you will be able to prove with, say, ABC divided by 999 that this ends up repeating itself. You're welcome to try it if you like. So, what's this? This is going to be 43.43 repeating percent. But it says round to the nearest tenth of a percent if necessary, so we end up with approximately 43.4%. Now, number 8, that's 3 3/4. That's equal to 3 over 100. Because 4 times 25 is 100, so 3 times 25 is 75. Okay, then, round to the nearest tenth of a percent if necessary, expressed as a percent. The 3 just gives us a 3 in the hundreds place. And 75 over 100, 375%. The percent proportion, it's this. Part divided by base is equal to the percent. When you take one of the numbers and compares it to the whole quantity, then you get the percent. You can show the percent as a ratio, as in the percentage over 100. After all, that is what a percent is. It literally means per 100. So find each percent. 12 is what percent of 16? Well, the part that we're trying to find the percentage of is 12, and the whole is 16. So 12 over 16 is equal to percentage over 100, if you like. So what you end up with is percentage is equal to 75. This is 3 over 4, and if you cross multiply, you end up with 75. So 12 is 75% of 16. What percent of 8 is 3? Well, 8 is the whole and 3 is the part. Three over 8 is equal to how many percent? 1/8 is 0.125 or 12.5%, and this is that much short of 1/2. So it's going to be 37.5%. Okay, guys, find the part or the base. Let the unknown be n. Okay, what number is 1.4% of 15? So n over 15 equals 1.4%. Yeah, basically you could have gone n is equal to 1.4% times 15, because 1.4% of 15 is literally the multiplication. Do it. But anyway, you're going to end up with 0.014 times 15. Now over here, what happens? Oh, we got 5 times 3. Hey, this is an even number. What happens when we multiply it by 5? Ooh, we get 0.07. And then times 3? Oh, that's 0.21. Okay, so that's n. 225 is 36% of what number? We literally got told 225 is equal to 36% of an unknown number n. Okay, then. As you can see, we didn't actually need to write out the percent proportion thing. Now, for this, let's use 225 over 0.36. It's 225 divided by 0.36. Oh, it's 625. Okay. Right, we could have done it without using a calculator because 0.36 is 9 times 0.04. And what's 225 divided by 9? It's 25. So 25 divided by 0.04, which is 1 over 25. So 25 divided by 1 over 25 is 25 squared. So 625. But, well, didn't feel like it. Use a percent proportion to solve each problem. Round to the nearest tenth. So, let unknowns be n. There we go. We don't need to put a let statement for everything now. Wonderful. It says use a percent proportion, so in other words, we actually have to use it. Okay, fine. 43 is what percent of 53? 43 over 53 is equal to n. N is approximately, because we can just divide 43 divided by 53, approximately 81.1%. That's rounded to the nearest tenth of a percent in this case, because we're expressing this in percent. What percent of 22 is 59? So 59 compared to 22 is how many percent? Well, we just divide. So 59 divided by 22. No, we get approximately 268.2%. Now, what is 93% of 522? That means n over 522 is equal to 0.93 or 93%. Depending on teacher, they may or may not be okay with you writing it like this right off the bat. Oh well. 0.93 times 522 gives us 522 times 0.93. Oh, it's approximately, because it's rounded to the nearest tenth, 485.5. Well, actually it's 0.46, but it said round to the nearest tenth. Even though this is not so long, a decimal. So what is 4.5% of 38? N over 38 is equal to 4.5%. N is equal to 0.045 times 38. So 0.045 times 38, approximately 1.7, because it's 1.71, the result. 60 is 26.6% of what number? 60 over n is equal to 26.6%. Look, if we weren't restricted to using the percent proportion, I would totally go 60 equals 26.6% n. Like, it's just the sentence translated directly into math. But alas, it is not to be. So n is equal to 60 divided by 0.266, because that's dividing this over. N is therefore 60 divided by 0.266 to give us 225.6 approximately, because that's to the nearest tenth. Finding percents mentally. When you're working with common percents like 10%, 25%, 40%, and 50%, it may be helpful to use the fraction form of the percent. For example, find 20% of 65 mentally. Oh, right. Others that you should probably remember are like 4%, which is 1 over 25, 5% for 1 over 20, 33 and 1/3%, obviously, 12.5% for 1 over 8, and so on. Find 20% of 65 mentally. That's 1/5 times 65, which is going to be 13. Exercises. Find the percent of each number mentally. 125% of 12. That's 1 1/4. A quarter of 12 is 3. So 1 of 12 plus a quarter of 12, that's 12 plus 3 equals 15. 10% of 130, that's 1/10 of 130, so it's 13. 10% of 900, that's 1/10 of 900, so that's 90. 66 and 2/3%, so 2/3 overall, of 72. 72 divided by 3 equals 24, times 2 is 48. 30% of 50, well, that's 3/10 of 50, or 3 times 5, so 15. 80% of 1100, oh, you're going to do 8 over 10 times 1100, that's 8 times 110, so 880. And 12.5%, oh hey, that's 1/8 of 640. So 1/8 of 640, 64 divided by 8 is what? Oh, 64 is 8 by 8. So it's going to be equal to 80. Percent equations are equivalent forms of percent proportions. The percent is written as a decimal in a percent equation. If you're questioning why this section is not right next to the percent proportion section, well, North American Math Curriculum Organization. Fun times. Yeah, don't overthink it. Solve each problem using the percent equation. Find 22% of 85. Well, let unknowns be n. It says use the percent equation. That's why we're not just going 0.22 or 22% times 85 and be done with that. So we actually have to use the percent equation, which is going to be n over 85 is equal to 22%, or in the percent equation, the percent is written as a decimal, so 0.22. Okay. So n is equal to 0.22 times 85. Hey, what's 0.2 times 85? Oh, it's 1/5 as much. So that's 17. Okay then. We're looking at 17 plus 1.7. So 18.7. Now, what about 52 is 20% of what number? We got 52 over n is equal to 0.20. So n is equal to 52 divided by 0.20. So in other words, times 5. 52 times 5 gives us 260. Now, solve each problem using the percent equation. Let's do some exercises. Find 3.5% of 280. It says use the percent equation, so we can't just go 0.035, so 3.5%, times 280 and be done with it. That means we have to use let unknowns be n. So n over 280 is equal to 0.035. N is equal to, we just multiply now, 0.035 times 280, and we get 9.8. Find 18.5% of 60. That's going to give us n over 60 is equal to 0.185. You may have to show the rearranging step initially, but eventually you'll get to the point where your teachers are like, whatever, as long as the result is okay. 0.185 times 60 is 11.1. 36 is 9% of what number? 36 over n is equal to 0.09, because that's 9%. So n is 36 over 0.09. That means n is equal to 36 divided by 9 is 4. So divided by 9 over 100. Oh, that's times 100 over 9. So you get 400. 2925 is 39% of what number? 2925 over n is equal to 0.39. So n is equal to, you multiply n over, divide this into the denominator, and you flip the sides. 2925 over 0.39. We can do this by long division, or we can do this with a calculator. What else could we do? 2925. Hey, that's 3,000 minus 75, isn't it? Okay. 3,000. If 3,000 is like 40% of something, then that number must be 7,500. Okay, so 7,500, and then we take off 1% from 40% of it. Oh, that's minus 75. Okay, it's 3,000 minus 75. Oh, okay, great. This is 7,500. That's n. 576 is 90% of what number? 576 over n is equal to 0.90. N is equal to 576 over 0.90, which is equal to 6 times 9 is 54. And then 4 times 9 is 36. So we're looking at 640. And let's do the subtraction to see if it works. So 640 minus 64 would leave us with 600 minus 24. Okay, yeah, it's correct. Wonderful. 24.2 is 55% of what number? 24.2 over n is equal to 0.55. That means we're looking at n is equal to 24.2 over 0.55. What happens if we cancel out a factor of 1.1? If we factor out a 1.1, we end up with 22 up here, and we end up with 0.5 down here. So we divide both top and bottom by 1.1. Because 55 and 242 are both divisible by 11. So, what next? Well, 22 divided by 0.5, so divided by half, is just times 2, so 44. That's the value of n. 25 is 125% of what number? Bruh. 25 over n is equal to 1.25. N is equal to 25 over 1.25, which is equal to 20. Yeah, that was quick. So 0.6 is 7.5% of what number? Oh, 0.6 over n is equal to 0.075. So n is equal to 0.6 over 0.075. And rearranging and simplifying, that gives us what? Hey guys, what happens if we factor out a 3 from both of these? We end up with 0.025, and we end up with a 2 up here. 0.2 divided by 0.025. N equals 8. Percent of change. The amount of change, whether increase or decrease, expressed as positive or negative, divided by the amount that you began with, gives you the percent of change. Like say we have the fish stocks, so the number of fish available, rose 10% last year. That's plus 10% over the course of the last year. If expressed as a percentage, of course. Find the percent of change from 75 yards to 54 yards. You express this with difference with the new measurement minus the old measurement. What does this do? Well, if the new measurement is bigger, then subtracting the old gives you positive. And if you divide by the old, you get how big is the increase proportional to the original amount. If the new measurement is smaller, then subtracting the old gives you negative. And you end up with a negative percentage, or initially you end up with a negative fraction or decimal, and you can change that into a negative percentage. If you get a percent of change that's positive, like explicitly labeled as positive, then it's going to be an increase. If it's explicitly labeled negative, then it's a decrease. But if you make a statement, you can have it either way and still have the percent itself be positive. Because, oh, revenues decreased by 10% last year. If you express that numerically, that's minus 10%. But if you say it, increase by 10% versus decrease by 10%. They have different meanings, but the number bit is shown as positive either way. So to find the percent of change, you have new minus old divided by old. That means 54 minus 75 over 75. Now 54 minus 75 will give you If it was 55 minus 75, you'd end up at negative 20. But 54 minus 75 gives you negative 21. It's one less. Over 75. So if you cancel out a 3, you end up with negative 7 on top and 25 on the denominator. So that means negative 7 over 25. Dividing by 25 is going to give you 4% for each point on top, which means that this is going to be negative 28%. The percent of change is negative 28%. However, you can state it as the percent decrease is 28%. Percent change, negative 28%. Percent decrease, 28%. Is that okay with everyone, I hope? Now, exercises. State whether each change is a percent of increase or a percent of decrease. Then find the percent of change. So percent of change means that you have plus or minus symbols associated. Percent of increase or decrease have no such symbols associated. Round to the nearest tenth if necessary. 20 inches to 16 inches, that's a decrease. Specifically, it's how much of a decrease? It's 16 minus 20 over 20. So negative 4 over 20. Or how much over 100? Negative 20 over 100. So negative 20%. Percent of change is negative 20%. From 8 years to 11 years, that's an increase, of course. Now, if you wanted, by the way, to state that this was a decrease of however many percent, it would be a decrease of 20%. Yeah, as you can see, sign, no sign. Here, the increase, we're going to end up with a percent of change is positive, however many percent. At least that's the convention I'm used to. It could be that in some conventions, you have no sign for positives when you state percent of change. 8 years to 11 years, that's 11 minus 8 over 8, which is going to leave you with 3 over 8, or positive 37.5%. Percent of change is positive 37.5%. And of course, when we write, if we wrote it as increase of, we just write 37.5%. Okay, from $8 to $2.5. Hey, this is rounded to the nearest tenth. So, okay, fine. This is a decrease, obviously, because the amount decreased. So new minus old divided by old, that's negative 5.50 over 8. So we're looking at 5.5 divided by 8. Oh, negative 68 0.75%, but because it said round to the nearest tenth, it's approximately negative 68.8%. The percent of change is this number. That would be our statement. From 800 men to 636 men. Man, this is a pretty high attrition rate. Usually the rule of thumb is that once a unit loses about 10% of its manpower, it is combat ineffective. So, as in no longer able to fulfill its tasks. So either this is a formation with a bit more buffer built into it than typical, or the training could be appreciably above average. 636 minus 800 over 800. So you're looking at negative 164 over 800. Too bad the number up there is not divisible by 8, because we could have ended up with just over 100, so in other words, percents. But it is divisible by 4. And once you divide by 4, dividing by 2 again is not that hard. So, 160 is 20 times 8. This is going to be 20.5 negative. And it's going to be, cross out the 8, it's going to be over 100. So in other words, we're looking at negative 20.5%. Yeah. The percent change is negative 20.5%. The percent decrease is 20.5%. From 198 pounds to 112 pounds. Well, you're looking at the new minus the old, which means this is pretty obviously a decrease. And you divide by the old. And this is equal to 112 minus 198. So 114 minus 200. In other words, negative 100 plus 12. Minus 86 over 198. Now, 86 is 2 times 43, 198. Yeah, we're going to have to go with the round to the nearest tenth. So that's going to be, oh, it's a bit far. 86 divided by 198. Oh, it's negative 43.43 repeating percent. So that is equal to approximately negative 43.4%. So our statement would be the percent change is negative, well, approximately negative 43.4%. The percent decrease, though, is approximately 43.4%. If you're wondering what samples happens to be doing in this chapter, if the sample is representative of the population, then it's proportional. The ratio of a particular outcome in the sample, so out of the sample's population, is proportional to how much of the overall population has that particular outcome or status. So it is representative if it's unbiased, selected without preference, and large enough to provide accurate data. Because if you only roll a die 5 times, you're going to conclude that it's impossible to roll at least one of the numbers on the die, which is obviously nonsense. If you only roll it 11 times, at least one of the numbers on the die is going to look way less likely than the other numbers. But if you roll it 6,000 times, well, you're probably going to end up with a relatively even distribution unless the die is unfair. A biased sample is not representative of the larger population. For example, asking people which gas station they like to visit while you are at a restaurant that's next to a gas station. Oh yes, because you totally aren't going to end up with more people who were at that gas station or live near there and are more likely to visit it. Okay. Depending on the sample method used, you can use a sample to predict the characteristics of larger populations. Unbiased samples include simplified random sample, usually just called simple random, stratified random sample, stratified random, or systematic random sampling. So what are these? A simple random sample is like you have your whole class, you put all their names in a hat, and then you pull random names from the hat. A stratified random sample is, suppose you have 3 classes, each with 30 students. So you want to survey a total of 30 students. Okay then, because there are 3 classes, you pick 10 students from each class. Or, say you want to survey both the teachers and the students. And you have however many teachers at the school and some number of students. You survey 10% of the teachers and 10% of the students at random. That's stratified because you separate them into different strata, different layers that you're sampling from, different groups. A systematic random sample is when you go, okay guys, here's the attendance list. We have 30 names here. Let's start at a random name and choose every third person ahead of that name and behind that name. That's systematic. There's a rhythm to it. There's a rule. But it's still a random sample. Because your starting point was random. Therefore, all the subsequent points that you jump to were also random. Now, biased samples include convenience samples, like the example I mentioned earlier with the restaurant next to the gas station. Or voluntary response samples. You get results like, oh, only people who care strongly about an issue bother to reply, therefore you don't know what the majority of people are thinking. You could also have a non-representative sample that's obtained by using certain methods, such as, well, if you insist on doing a survey by telephone in like 1930, you're going to end up with only the people rich enough to own telephones responding. And you won't get the opinions of everybody who doesn't own a telephone. Now, in the modern times, that still applies. If you do an online sample, it's only people who are wealthy enough to have internet access who will respond. So most of the developing world, yeah, they don't have the opportunity to, well, okay, they could use public facilities, but very few people would probably care enough to go to a public facility, like say a library, if they have libraries, or any form of public facility where they can actually access the internet that is accessible to them. If they have that, even if they have that, not that many people would probably be enamored enough with any given issue to bother responding. So yeah, that's a problem. Okay, example 1. To determine the popularity of a political candidate, 5 people are randomly polled from each of 10 different age groups of eligible voters. Identify the sample as biased or unbiased and describe its type. This seems unbiased. More or less. Why? Well, if these age groups of eligible voters are differently sized, then you get overrepresentation of the smaller groups. If the voter groups are roughly equally sized, this is okay. Large, this is unbiased. Otherwise, well, imagine you have 5 people in the 2 oldest groups each. So you end up polling all of them. Meanwhile, of the 500 people in the youngest voting group, you only polled 5 of them. That means the older people's opinions would be overrepresented in your sample. But if you define the age groups so that each group is roughly the same size, there's such a thing as rounding error, okay? Like if you're trying to poll 1% of each group, and you're supposed to poll 4.93 people from this group and 5.21 people from this group, yeah, close enough. So if the voting groups are roughly the same size, this is unbiased. This is a stratified random sample. Find random. Of course, if they're not roughly the same size, you have a problem. Now, to determine the number of first-time visitors to a mall, every 15th shopper to enter the mall was polled. And there were 3,000 total shoppers in the mall, and of the shoppers polled, 26 shoppers were in the mall for the first time. Is this sampling method valid? And if so, about how many of the 3,000 shoppers were in the mall for the first time? So 3,000 times 1 in 15 equals 200 polled. This is a systematic random. Tick random. And it's about as unbiased as you're going to get. As can reasonably be done on any given day. However, we're looking for the 3,000 shoppers in the mall today as our population, not the however many shoppers that are going to be in the mall throughout this week. Big difference. Because if you're polling on say Sunday or Saturday. So on the weekend, you're going to end up finding more new shoppers who are exploring a new mall that they're not familiar with. Whereas on weekdays, people tend to not have that much time to wander around and resort to more familiar installations. Okay. This is for this particular day. So 200 polled. 26 new out of 200 is equal to how many out of 3,000? Well, that there be n new shoppers. This would rearrange to give you n is equal to 3,000 times 13 over 100. So you're looking at n is equal to 13 times 30, which is 390. There are 390 new shoppers. This is, of course, approximate because it's estimated using a sample. Exercises. To determine the average number of hours that students study, members of the math club are polled. No. This is biased because the math club are likely to study rather more than average. And it's a convenience sample. Because they only sampled one particular group that was convenient to access. Yeah, this is probably something that a math club member wanted to do in the first place, to figure out the average number of hours students study. And yeah, the other members should hopefully have stopped him or her in time, because this is terrible. Like, this is really, really biased. To determine the consistency of a printer, 100 printed sheets are randomly checked and 3 sheets were found defective. What type of sampling method is this? This is probably simple random. Simple random, probably. Because it doesn't specify. It could be that these printed sheets were randomly checked by choosing every third sheet or something. In which case, that would be systematic random. So, about how many defective sheets would be expected if 3,000 sheets were printed? Defective sheets be expected. Then you got 3 sheets defective out of 100 is equal to D sheets defective out of 3,000. So you're looking at D is equal to, well, you can cancel some here. 3 times 30 or 90. So usually you write this like so, with the variable on the left. About 90 defective sheets expected in 3,000. Okay, well, that is it for this chapter. Remember that when you have an unbiased sample, it's representative of the population, so it is proportional to the same ratio in the population, and you can use the proportion to solve for your expectations in the population, or perhaps for the population size. So, see you next section.